Hi, as was said, my name is John Sallay, and we're going to be talking about PMTs. Just note, I work at a little place called B Cubed. It's a cool place with a dark blue slide, and we make cool stuff, both hardware and software, and we've got good benefits. So if you're interested, come talk to me, or if you're interested in being convinced to be interested, come talk to me. So many of you are familiar with PMTs already, but we'll give a brief overview. I find that it's a part of GNU Radio that a lot of people avoid learning about. Talk about why we're going to do something new, what that new thing is, where we're at, and where we're going. So PMT is a super fancy kind of sort of acronym for a polymorphic type. I don't feel like that's the most meaningful term. I like to think of it as a Python dictionary in C++. And frequently we have data that may be a center frequency that's expressed in floating point, and then we'll have a burst index number or something like that that's an integer, and maybe we'll have a string description. We want to jam all these together, just like you can very easily do in Python, but not easily do in C++. And that's where the genesis of PMTs came from. There's also serialization, deserialization functions, because we may want to run a flow graph or a set of flow graphs on multiple nodes and be able to transfer the data easily between them. And so the goal of PMTs is to make that really easy. In GNU Radio, there's two primary uses for PMTs right now. One is for asynchronous messages. Those are transferred using PMTs. And then the data tags, you have your main data stream, and there's a parallel tag stream, and the data in that tag stream is also comprised of PMTs. So PMTs can be hard to use. There's weird, sometimes inconsistent function names. Good example is that you convert from long to a PMT, but if you'd like to check if something is a long PMT, you ask, is it an integer? There's also fun functions like a car or CDR or CAAR, and it can just sometimes not be the most friendly of interfaces. Where I got involved in this is I had a PMT dictionary, and I just wanted to make sure that the values that someone was passing me were correct. And I got really frustrated because message validation is really hard right now in the current interface. There are certain aspects, especially if you have a lot of data that you're working with, where the performance can be really slow. And when I deal with PMTs, I get seg faults all the time. And at least for me, it's difficult to be memory safe there. So I wanted to make something that was easier for me, and hopefully is easier for you. And so a big emphasis of the new PMTs is to use modern C++ and to have things just work without a lot of effort on your part. And so here's some example code using a PMT map. And so just kind of walking through here, I declare some variables, and then I declare some variables and then use a C++ initializer list, which looks almost like instantiating a Python dictionary. Not quite as nice, but pretty close to the same syntax. You can also access it just like you could a dictionary in C++ or Python. So you can ask for a key, get the value out. At the bottom, I am printing the dictionary out. And so types are converting in a friendly way. You don't actually have to know that in the for loop at the bottom here that value is a PMT. The operator is defined the streaming operator is defined for value in a way that it will be able to print out for you. And so to me, at least, this is a nice, friendly way to deal with maps. We also have vectors, another common data type. And so you can declare a vector with an initializer list. You can use all of the STD vector constructors are valid here. So the second one is constructing a vector of size 4 where all of the values are initialized to 1.0. The hope being both with the map and the vector that if you know how to use a standard template library mapper vector, then you know how to use the PMT mapper vector. You can do range-based for loops. You can do equality operators, which took some effort, but I felt was worthwhile. It's really nice to not have to know what kind of PMT you have to be able to ask if it is something else. There's also PMT scalars and PMT strings. Those are more straightforward. I didn't produce examples here, but they're fairly simple. The new PMTs encapsulate most of the functionality of the previous ones. Last year, I presented kind of the idea of this, and Josh Mormon was helping me out, and a few weeks before GRCon, he was doing some benchmarking and sent me the most disappointing chart I've ever seen, which is this top chart. A very important operation is that we want to serialize a vector or a packet data unit, PDU, and send that from one flow graph to another, be it on the same host or on a different host. And for small vectors, the new PMTs were a little bit faster, but for large vectors, they were actually slower. And having a nice, modern C++ interface is great, but if I had to pick between a good interface and fast performance, I would generally pick the fast performance. So I discovered what the issue was, and sadly, it involved a major rewrite of the library. There were some design considerations or design flaws in there. But after the major rewrite, we can now see that the serialization time is, for the old PMT and the new PMT, is linear in both cases with the size of the vector, but the scale is much smaller in the new case. So it's faster in every case, which makes me happy. Thanks to whoever clapped there. And then Josh Mormon has been doing a great job on the GNU Radio 4.0. I'm going to call it a rewrite. And this is fully integrated in there. Now this is, the plan is that this is going to be the new PMTs in GNU Radio 4.0. And if you were to check out 4.0 today, you would be using these PMTs. So some places that I'd like to go from here. If you remember, this all started because I really wanted to check and make sure that the dictionary that someone handed me had the fields and types that I wanted. And I sadly have not fixed that problem yet. What I would love to do is integrate something similar to JSON schemas, where you're able to declare, this is what my message should look like, and it will validate all of those types for you. And there's a C++ library that lets you define your own JSON schema-like structures that I'm looking at for using for that. There's also a lot more benchmarking to be done. We would not have known of the major design flaws had Josh not done some benchmarking for me. And so there's a plan to go through and benchmark all the major functions and compare them to the previous PMTs because we want to make sure that this is better, not just from an interface perspective, but from a performance perspective in any way possible we can. I have started doing this and already found a few areas for potential improvement. And so the plan is to just keep going from there. Along with that, I don't have the exact numbers for code coverage. It is pretty high right now, but given that this is something that will be used all over the place in GNU Radio, and I'm hoping it will be more user-friendly to use in GNU Radio, I'd like to have 100% coverage in there. And then I like Linux. Linux is good, but sometimes people disagree with me on that. And there are already a few cases where people have tried to build the library, say using Clang, and it didn't work. And so we need to go through and make sure that we build this on different operating systems, architectures, different compilers, and make sure that this is going to work for all the use cases that we're using. One note that I did not include in here is that this requires features from C++17, and so you will need a reasonably modern compiler to use this. But if I'm not mistaken, GNU Radio is already at C++17, correct? Yeah. And so if you're running GNU Radio, the latest, then you should be good there. And then just make sure that that this is supporting GNU Radio 4.0, and that any features that are needed to help there will be supported. So that's where we're going. So thank you all for the time. If anyone is interested, the repo is available on GitHub. It is part of the main GNU Radio project. And there have been a few people who I don't know who have made pull requests, which is great, including one person who has no association with GNU Radio. And you can contact me as well. I've also got some coworkers here from B-Cubed, which is a great place. So feel free to reach out. Thanks.
Thanks. That was really informative.